Hello everyone, welcome to MemoNeet. I am Prajita, your chemistry SME. I hope all of yours preparation is going well. All of you are doing well also. So how is the preparation for BPT 6 going on? So we have revised almost all the chapters that are going to come in the BPT 6. Okay, we started with electrochemistry, then structure of atom, chemical bonding and molecular structure, and in the last lecture we revised solutions. So today we are going to revise some basic concepts of chemistry. So again, as the name suggests, this is a very basic chapter from your class 11. That is the first chapter that you have. But again, it carries some weightage, like some questions have been asked in the NEET examination from this chapter. So we will be just revising the important topics of this chapter so that you can get an idea about what are the important topics that you need to cover, and I hope you people have solved the questions for this chapter already, like the in-text questions and the exemplar and the PYQs as well. But one thing I am noticing here, that you people are not commenting on the videos. I asked you to comment on the video and let me know ki what are the topics that you want me to explain, or if there is anything that is not understood, so you want us to explain that to you. So students, if you are going to comment on the video, then only we will get to know that what do you want to study, right? And how do you want to study. So please let us know your inputs as well through the comment section, how you are liking the lectures or not, or what else do you want in our video lectures, that what else should I cover. Okay, so you can also give your inputs and we will definitely work on that. All right, so keep on commenting, keep on interacting with us. All right, so let us start with the important topics of this chapter. Firstly, we talk about matter and the classification of matter. We know, we have studied it in our lower classes many a times, that anything that has mass and occupies space is called matter. And based on the chemical composition, we classify matter into pure substances and mixtures. So students, pure substances are the ones which have constant composition and constant properties throughout the mixture. Okay, constant composition and constant properties throughout the substance. Okay, so pure substance may we have elements and compounds. Now we will see that what are those. Then if I talk about mixtures, so mixtures are the ones that are formed by the combination of elements and compounds. So they are having variable composition actually. Means the composition is not fixed, the composition is variable, and of course if the composition is variable, the properties will also be variable. Okay, so that is what we talk about the mixture. Now mixtures can be homogeneous and heterogeneous. Now if I talk about what are elements, so elements are your pure substances and they are the simplest form of matter. Means you cannot break down any element into something else. Okay, like let's say if I'm having oxygen, hydrogen, I cannot break this oxygen and hydrogen into something smaller. So that's why we say that they are the simplest form of matter. Okay, and you know that all the elements consist of one type of atoms, like they'll have one type of atoms respectively, and this smallest unit of element we call it as atoms, right? So you know that total number of elements that are known are 118. 98 elements occur naturally and around 20 are formed by artificial transmutation. You know the examples: sodium, potassium, magnesium, aluminium, and many more are there. Oxygen, hydrogen, carbon, nitrogen, all these are your elements. Now when these elements they combine together chemically, so we get compounds. Okay, so compounds are formed by the chemical combination of elements, and that too the chemical combination of elements happens in a fixed ratio. Okay, if two or more elements they combine with each other in a fixed ratio, so we will be calling it as a compound. For example, water, it is formed by the chemical combination of hydrogen and oxygen. We have carbon dioxide, we have glucose, C6H12O6. So one difference between elements and compounds is कि elements को you cannot break down into smaller parts, but compounds can be broke down into their elements by chemical methods or physical. All right. Now students, if we talk about mixtures, so mixtures are formed by the physical combination of two or more pure substances in any ratio. See, this is the difference between compound and mixture. In mixture, you have two or more pure substances which are combining physically, okay, not chemically, but they combine in any ratio. So that is why variable composition is there, and chemical identity of pure component remains maintained in the mixture, okay. Now there are two types, homogeneous and heterogeneous. Homogeneous mixtures are those where composition is like constant throughout, constant composition is there, okay. Whereas if I talk about heterogeneous mixture whose composition varies for each and every part, means it is not constant, okay. So like soil, concrete mixtures, so these are the examples. So this was very basic thing that we had in this chapter. Then if I talk about physical quantities and this measurement, so students questions could be asked. So questions can be asked from this topic also, like they can ask you the symbols also. So students, there are two types of units. We have fundamental units, which are the ones that cannot be derived from one another and they cannot be resolved into any other units. So there are like 7 such units. For time, it's second. For mass, kilogram. Length, meter. Temperature, Kelvin. Electric current, ampere. Luminous intensity, candela. And amount of substance, mole. So these are the 7 fundamental units that we use. Then derived units can be there, like velocity, meter per second. Area is there, meter square. Volume is there, cubic meter, okay. Density. Those similarly, these units, they are function of more than one fundamental units, okay. Now in chemistry, the measurement of temperature is very important, right? So in this case, we have three scales: Kelvin, degree Celsius, and degree Fahrenheit. But you know that Kelvin is the SI unit, that is the standard unit that we use, all right. So Kelvin is mostly used, and if you want to convert degree Celsius to Kelvin, so you just add 273 to it. And if you want to convert Kelvin to degree Celsius, subtract 273 from it. And 0 Kelvin is the absolute zero temperature. Okay. Absolute zero temperature, which is the minimum theoretically possible temperature value, which is minus 273.15 degrees Celsius to be precise. Okay. So that is the temperature. Now another important topic, and I have noticed that a lot of questions have been asked from this particular topic, that is significant figures. So you must know about significant figures. See, these are actually the meaningful digits which are known with certainty. So the important thing is that you must know the rules about the significant figures. The very first thing is all non-zero digits are significant. Like if I have 285, there are 3 significant figures. If 0.25, there are 2 significant figures. Means the non-zero digits are significant. 0 preceding to the first non-zero digits are not significant. These zeros indicates the position of decimal. Like if I have 0.03. Now we are saying 0 preceding to first non-zero digit, means these zeros, they are non-significant. So only one significant figure is there. If I talk about 0.0052, so how many significant figures? 2 significant figures are there. Okay. Then zeros between two non-zero digits are significant. Like if yes, now these zeros are between two non-zero digits like this 2.005. Now this will be having 4 significant figures. This you must know. So knowing the rules are important because they can give you in question how many significant figures are there. Okay, so you can count them only when you know the rules. Next is zeros at the end or right of a number are significant provided they are on the right side of decimal point. Okay, now zeros that are present at the end. Okay, we were talking about preceding zeros. Now the zeros that are present at the end or right of the number, they are significant provided they are on the right side of a decimal point, like 0.200. How many significant figures it will be having? 3. Okay. And if I talk about counting number of objects, so they can have significant, infinite number of significant figures because they are exact numbers. Like for 2, I can write 2.000000, so it will be having infinite number of significant figures. Okay. Now, if we talk about addition and subtraction of significant figures, so you have to keep that in mind, students. If the addition or subtraction of numbers, they are having different precisions, the final result should be reported to the same number of decimal places as in the term having least number of decimal places. Now, let me explain that. Let's say if I'm adding these three numbers, answer is coming out to be 12.06. Now, this final result has these two decimal places, but there is one number 2.3 which is having just one digit after the decimal. Okay, so it means I just have to report the answer as 12.0, which is similar to the least number of significant figures. Okay. Next is, if I talk about multiplication and division of the significant figures. So multiplication and division may the final result should be reported up to the same number of significant figures as present in the least precise number. Okay, like you multiply this number according to the final, according to the result, the final result will be 0.024. Okay, because there are three here significant figures, two significant figures, and here also two significant figures. Okay. Now the important topic is laws of chemical combination. So there are different laws that we have studied. Law of conservation of mass, very simple, that mass can neither be created nor be destroyed, means total mass of the reactants will always be equal to total mass of the products. Okay. So that is the thing. Next is law of definite or constant proportions. We call it as law of definite proportions and law of constant proportions as well. So students, according to this law, pure chemical compound always consists of same elements combined together in a fixed proportion by weight. Let's say if I am talking about the carbon dioxide. Carbon dioxide is formed in a number of ways, like by burning of carbon in air, but by the decomposition of limestone, by action of dilute HCl on washing soda. So all these samples of carbon dioxide, whether we take it from, okay, wherever we take it from, so the ratio of the masses of carbon and oxygen is 12 upon 32. So it will come out to be 3 by 8. So in every, here you can say that in every sample, the ratio of carbon and oxygen is 3:8 by weight. Okay. So that is going to be there for every chemical compound. That is the law of constant proportion. Now law of multiple proportions. If two elements they combine to form two or more than two compounds, weight of one element which combines with a fixed weight of other bears simple whole number ratio. Let's say if I am talking about hydrogen and oxygen, they combine to form water as well as hydrogen peroxide. So the fixed weight of hydrogen is 2 grams here. It is combining with 16 grams and 32 grams of oxygen. So the ratio is 1:2. Okay, so here we can say that masses of oxygen, which is 16 and 32, which combine with a fixed mass of hydrogen, bear a simple ratio. That is 1:2. Okay. See, this type of questions can be asked in exam. They will give you a certain example and you need to find out which law is governing that. Okay. Or like they will give you the statement of the law and you have to find the correct example for that. So that is why knowledge of these laws is important. Next law is Gay-Lussac law of gaseous volume. It says under similar conditions of temperature and pressure, whenever gases combine, they do so in volumes which bear simple whole number ratio with each other and also with the gaseous products. Like here, if we are having hydrogen and chlorine gas, they are combining to form HCl gas. So what will happen? One volume of hydrogen will combine with one volume of chlorine, which gives us two volume of HCl. So the ratio is a simple whole number ratio, 1:1:2. Same goes with nitrogen and hydrogen. One volume of ammonia combines with three volumes of hydrogen to give two volumes of ammonia. Okay. Next is last law, which is your Avogadro's law. It says that equal volume of gases at same conditions of temperature and pressure contains equal number of molecules. Okay, let's say if I am having one volume of hydrogen and one volume of oxygen. Okay, so two volumes of hydrogen will combine with one volume of oxygen to form two volumes of water vapor without leaving any unreacted oxygen. Okay. Now next is Dalton's atomic theory. So Dalton was the one who gave us an idea about the atoms. He said matter consists of indivisible atoms. All the atoms of given element have identical property, including identical masses also. And he said atoms of different elements will differ in mass. Compounds that are formed when atoms of different elements combine in a fixed ratio, and chemical reactions which involve reorganization of atoms, they are neither created or destroyed. So Dalton actually said that atoms are neither created nor destroyed in a chemical reaction. Next is atomic mass. So students, atomic mass we have already studied. So we actually take the relative atomic mass. So it is actually the mass of an element. It means how many number of times an atom is heavier than the atom of carbon 12. So in this case, the atomic masses that we are using are the relative atomic masses, and it is denoted in AMU. AMU means the atomic mass unit. So 1 AMU is equal to 1/12 of mass of carbon 12. Okay. So this is also called as unified mass. Now in some places instead of AMU, simply U is used, which means unified mass. But if we are having isotopes, most of elements are having isotopes. Okay, means they are different atoms of the same element with different mass numbers and same atomic number. So the atomic mass of element will be average of the atomic masses, and it may be defined as the relative mass of an atom. Okay, so that we will be taking as. Now if I talk about molecular mass, means if I have to calculate the mass of any molecule, it will be the sum of atomic masses of all the atoms present in the molecule. Okay, and it is obtained by multiplying the atomic mass of each element by the number of atoms and adding them together. Like if you are having CH4, that is methane, so you will take the mass of one carbon atom plus 4 into the mass of hydrogen. So 12 plus 4 will give you 16U. Now same goes with formula mass. Now in formula mass, what happens is, if we are having ionic compounds like NaCl is there, KNO3, Na2CO3 is there, they are not having any molecules, means they are not single entities, but they exist as ions closely packed in a three-dimensional structure. Okay, so like a lot of sodium ions will be there, a lot of chloride ions will be there, and they will be forming a three-dimensional structure. So in that case, we are just not having any molecule, so we cannot calculate the molecular mass. In that case, calculating the formula mass. So formula mass, again it will be same, the mass of the atoms present in one formula unit of the compound. So our one formula unit is NaCl. So in that case, we will take the mass of sodium atom plus mass of one chlorine atom. So here for a formula mass of sodium chloride will come out to be 23 plus 35.5, which is 58.5 U. Now the most important topic of this chapter, mole concept. So you will be getting many questions related to this chapter in NEET exam. Like they will give you certain number of grams of some element, and they will tell you which will be having the highest number of molecules in it or the highest number of atoms in it. So that's what you have to do. So you know that in mole concept we know 1 gram atom of any element has same number of atoms and 1 gram molecule has same number of molecules, and that is experimentally determined, which is 6.022 into 10 to the power 23, and this is called the Avogadro's number. Now this flow chart that I am giving you, it's very important to understand the like the mole concept. Like let's say if I am having number of moles, if I am having let's say 5 moles of water, okay, so I need to find out the number of particles in water, means here it will be molecules, so I will be multiplying it with Avogadro number. See, so arrow is given now, so 5 multiplied by Avogadro number will give you this much particles, this much molecules of water would be there. If let's say I'm having certain number of water molecules that are given to me, okay, and I need to find out the number of moles, so I will divide it by the Avogadro's number. This is what these arrow means. Okay, now if I am talking about the amount of substance in grams, okay, let's say if I am having 4 grams of hydrogen, and I need to convert it to number of moles, so I have to divide it by the molar mass of hydrogen, means 2 in this case for hydrogen. Okay, so it will be 2 moles. Similarly, if I have to convert moles into the amount of substance, let's say if I'm having 5 moles of water again, okay, 5 moles of CO2 I'll take, so I have to multiply it with the 44 grams, which is molar mass of CO2, so it will be coming out to be 220 grams. Okay, last one is volume of gas. So you know 1 mole of any gas at STP occupies 22.4 liters of volume. So you have to convert from mole to liters, multiply it with 22.4, otherwise volume to moles, so divide it with 22.4. So that is why I have given you this flow chart. So if you are not able to remember the things, just draw this flow chart and solve the questions. It is very easy to do that using this. Okay, fine. Okay students, so now if I talk about percentage composition, so the percentage composition means how much mass of that element is present in that compound. Okay, means the percentage of that element. So mass percent of an element will be mass of that element in the compound divided by the molar mass into 100. Let's say if I want to calculate the percentage of hydrogen in H2O. Now how many hydrogen atoms are there? 2. So mass of hydrogen is, you can take exact value 1.008 divided by molar mass of water, which is 18.02, and multiply it with 100. So you will be getting 11.18%. So means 11.18% of hydrogen is present in your water molecule. Okay, and after that you can similarly calculate it with the help of for oxygen with the help of this formula. Okay, next students is empirical and molecular formula. So you know empirical formula gives you the simplest whole number ratio of atoms present in one molecule of the compound. Okay, let's say if I'm having H2O2, so this is the molecular formula. If I have to find the empirical formula, so it will be HO. Okay, because that will be the simplest ratio, because the ratio here is 2.22 ratio 2, it is 1. And if I talk about molecular formula gives us the actual ratio of atoms present in the compound. Like for hydrogen peroxide, the molecular formula is H2O2. For glucose, it's C6H12O6. Okay, and molecular formula is N into empirical formula, and N is the common factor which we can calculate. So let's say this question was asked in your NEET 2024. So how to find out the empirical and molecular formula? So it has given that a compound contains 32% of A and 20% of B and remaining percentage of C. Okay, the atomic masses they have given you already. Atomic mass of A is 64, B is 40 and C is 32. So you have to find out the empirical formula. So for finding out empirical formula, students, first of all you have to find out the number of moles. Number of moles is given mass upon molar mass. So if 32%, 20% is there, means it's 52 na. So C will be 48%. Okay. So number of moles we will find out given mass upon molar mass, which is 1 by 2. So if I talk about the number of moles in this case, students, so it will be given mass upon molar mass. Okay. So here it is 32 upon 64. So it will be 1 by 2, or you can say 0.5 mole. Here it's 20 upon 40, again 0.5 mole. And 48 upon 32, it's 3 by 2. So it will be 1.5. Now once you get the number of moles, so you have to find out the simplest ratio. How to find out the simplest ratio? By dividing these values by the smallest value. So smallest value in, so students, the simplest ratio will come out to be 0.5 upon 0.5, which is 1. Here also 0.5 upon 0.5, which is 1. And 1.5 upon 0.5, which is 3. So these are the whole numbers that we are getting. So empirical formula of the compound will be ABC3. So this is how you are going to find out the empirical formula. Now if I talk about stoichiometric calculations, so you know it deals with the calculation of masses of the reactants and products involved in the chemical reaction. Like if we are having this balanced equation, methane plus 2O2 gives CO2 plus O2. So what are the information that we are getting from this equation is methane and dioxygen are your reactants and CO2 and water are the products. G indicates the that all the reactants and products are gases. Coefficient, this is the coefficient 2 here now. It is your stoichiometric coefficient. And according to this reaction, what we can get to know is 1 mole of methane reacts with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. Similarly, 1 molecule of methane will react with 2 molecules of O2 to give 1 molecule of CO2 and 2 molecules of water. In the form of volume, we can also tell 22.4 liters of methane will react with 44.8 liters of oxygen to give 22.4 liters of CO2 and again 44.8 liters of water. Similarly, 16 grams of methane will react with 2 into 32 grams of oxygen to give 44 grams of CO2 and 2 into 18 grams of water. So from these information, anything can be asked for the particular question. So you must know about the stoichiometry and the stoichiometry calculations for any such reaction. Okay. So for that again you will be using these formulas, mass, how to convert it to moles and how to convert it to number of molecules. Then you can solve any such question. So this is a very basic chapter, students. Okay. And some important concepts were there. Mainly please focus on stoichiometric questions related to significant figures. Then we have some questions related to mole concept. So try to solve the PYQs as well. Okay. And it will be easy for you to understand this chapter. Okay. So for that our BPT 6 lectures are complete. So I'll be meeting you all in the next lecture where we will be studying the topics for your BPT 7. So all the best for this particular test. In case you are having any doubts, please let us know in the comment section. Okay. So also do like and share this video with your friends so that they can also prepare for their NEET examination. So thank you so much. Take care.